Yousuf Jawwad. I want to thank you, Saim, for inviting me to talk to you guys about linear deployment experience. I'm the founder and CEO of Quantum, and we have been working with distributed system, or you may call it microservices, for the past 15 years. But before I go on further and share with you learnings from our experience dealing with deployments in distributed systems, I want to talk about three things. And these three things are, when dealing with distributed systems, what motivates me, what amazes me, and finally, at the end of the day, what really, really delights me. So let's talk about distributed systems at first. Distributed systems like concurrency is very, very hard. And at some point in a project life cycle, they become inevitable because you at one point you cannot scale up, you have to scale out. And then when we start dealing with distributed system, it's a completely different application paradigms, and we kind of see sort of failures that we haven't seen before. If we take a more academic approach to the whole thing, we can define these as, okay, there are crash failures, there are Byzantine failures. Modern cloud applications are nothing but a set of integrations. So crash failures are, for example, the third-party API is down, or they sort of is choked. So we get sort of under capacity or high latency or uh, connection timeouts and things like that. And these sort of failures are called crash failures because we sort of get a response that, okay, the service that we are trying to approach is not available. People have come with approaches with, okay, retries or rate limiting to deal such kind of failures. And for the past 15 years, in every programming language, there are libraries to deal with these failures. But what we have seen is everybody who starts with these systems sort of build their own solutions on top of libraries. But thankfully, as people have developed, application developers or framework developers have looked at these kind of problems, and they have developed frameworks that sort of built on top of libraries that are under it. These frameworks are called Azure Durable Functions, or if we are more adventurous, there are Dapper out there. But at the end of the day, it remains a state management problem, because at the end of the day, we are dealing with CAP theorem: consistency, availability, and partitioning. Since we have both availability and partitioning, and we require consistency, so most of the challenges that we sort of have with distributed system is of consistency. Over the past 15 to 20 years, there have been standardization and dealing with these type of failures. There is Paxos that came out of Google, then there is Raft that sort of aims to simplify it. If we want to go a little bit backwards, there was ViewStamp application. So there are things like that, but at the end of the day, we are building on top of it. But thankfully, after 12, 13, 14 years, we now have frameworks. And why I'm talking about temporal here, because temporal is such a beautiful abstraction on top of everything that we are failing for the past 15 years, that it not only provides visibility into the into the distributed state of the system, but the overall execution, thus providing a linear development experience. So what motivates me, anything that is linear. And what I mean by linear is that, okay, no matter how much you scale your application, the deployment or development frequency is the same. You are not impacted by it. So, what motivates me is coming to a common understanding of a system and then developing tools around it uh, that sort of make things linear. Now, I want to talk about something that amazes me. And what amazes me are abstractions. If we are looking at a system and we are working with a system for a very long time, we start to see common patterns arise to sort of that can encapsulate multiple problems. But what is an abstraction? The abstraction is sort of a beautiful interface on top of a very ugly interface. If we want to understand something, this is what Tenenbaum in his book of Modern Operating Systems uh, sort of say that, okay, abstract, if we go to low level, we sort of have a ugly interface. And if we go on to a higher level, we get a very beautiful interface. What do I mean by low level and high level? Uh, what I mean is that if we are looking at a system, hardware is a low-level interface. There are hard drives, there are CPU, there is memory, there is motherboard, and then there is coordination that is taking care of it. But the operating system provides an interface on top of hardware that makes it easy for application developers to sort of operate the hardware. So it doesn't matter to the operating system if your sound card in the system is from Creative or Microsoft or Nvidia or Intel. It's just a graphic cards. If we want to go into a little bit more detail, we can say that, okay, operating system is an ugly interface and database is an abstraction on top of it, is a beautiful abstraction on top of it, because database, we are only interested in data. We are not interested in files. We are not interested in directory. We just want to know that, okay, this is a piece of data and this is how it is related to something. So the lower level, we are dealing with a lot of stuff. Then there is an abstraction on top of it that deal with common problems and provide a new interface. And every abstraction in its uh, uh, in its in its own is a completely different thing, is an entirely new world. Pat Hallen defines that, okay, the more low level you are, the system is more aware, and the higher level you go on top of it, uh, uh, the system become agnostic. It doesn't need to know what is happening low level. For example, if a mobile application, we are browsing through Instagram, we don't know that there are millions of servers coordinating with each other to sort of fetch with a lower latency. That is an abstraction that we don't need to know about. It's the lower level is very aware. The top level, the Instagram app, it's very agnostic. It doesn't need to know that, okay, your content is being edge cached. And the beauty of the interface is the API that sort of covers the surface area. So the quality of the abstraction depends upon the API that produces it. So this looking at a very beautiful abstraction on top of a very ugly interface is something that really delights me. And why shouldn't it? Our entire computer industry is built upon the concept of building abstractions, right? Now I want to talk about something that really pleases me. And what does really pleases me? It's the concept of bringing order to the universe. And since I'm here to talk about the deployment or the operations, anybody who has worked with cloud knows that as applications become more and more distributed, managing infrastructure and operations become very hard. There have been solutions that sort of provides visibility into it, but making sense of that entire things depend upon the quality of the personnel operating the system. If we want to understand what do I mean by volatility and durability and visibility, I want to take you back around about 10 years ago when sort of the craze of microservices and everything started happening. And I would say that, okay, let's start, we start with a project that, and we pick a framework like Django. What does the deployment look like? It's very simple. We code, we build, we test, we deploy, and that is it. Our GitHub Actions or Circle CI or CodeShip or Jenkins take care of the entire pipeline. We just have to write a little bit of YAML, and the entire process takes place. How does it start? Okay, it starts like that. That okay, deployment experience as the project grows, it should stay linear. It should stay linear. But this is not what happens. Why it doesn't happen? Let's look at our project. We started the application. We are transferring funds. Our senior developer said that, okay, it needs to be ACID. I look at the Django documentation and I say, what is ACID? Oh, fine. If one transaction fails, we need to able to roll back. And I look at that, okay, Postgres provides ACID compatibility, role transaction capability. So I say that, okay, let's start using, and Django provides a sort of a wrapper on top of it in terms of atomic. And I say that, okay, if I wrap this entire function around the atomic wrapper, I would be able to create an atomic transaction. So for example, in the code above, if the transaction A fails, it will automatically roll back. It will not commit to the database. Now what happens is that our project is very popular in the market, and what the system administrators are doing is adding more capacity to the system. And there comes a point where we cannot scale up anymore. Now we have to scale out. And there is a meeting, and we look at the Django documentation again, and we say, fine, let's shard the database. We will have debit in one database, and we will have credits in the second database. And what happens is, I I look at Django documentation and I say, fine, Django provides an interface on top of uh, on top of the atomic protocol, and we can use two databases. So I decide to shard that, okay, my debits should be in one database and my credit should be in another database, completely different. And I'm happy I do this. But obviously, this is not completely atomic and not completely ACID compliant, because now we are dealing with two different databases. Our wrapper, even if the transaction number 2 fails, transaction 1 is already committed. We are not leveraging the ACID compliance of Postgres database below. And now our system is not in the state that we want it to be. One state is not compatible to the second state, and our entire financial ledger has collapsed. And this is the moment where everything changes. This is the moment where we have a meeting, everybody is there. We are going to talk about microservices. We are going to talk about CQRS. We are going to talk about Saga pattern. We are going to talk about event sourcing. And it's not a happy company anymore. Coming to work is different. The development is different. The debugging is different. And the seniors that I am looking up to are now moving on to the DevOps, like we call it the DevOps, and uh, it is difficult. So what happened was that now we are into an array which is completely different. Thankfully, for the past 15 years, we have been looking at development of these systems from the first principle, and we have come to frameworks like temporal or dapper. Right now there are plenty of small startups that are going on around in terms of durable executions, but what we are not looking at, that how at this particular moment the operations change suddenly. The cost of deployment and pushing more features to the market um, are less expensive than operating the beast. At this particular moment, our normal deployment experience has evolved from code build, test, deploy, monitor, and incident response. So this is what the deployment experience look like at this particular point in time. But when things change, now we have these kinds of problems. We have merge conflicts to deal with because the team is has become bigger. We have dependency isolation problem. We have integration testing problems. We have every team wants to say that, okay, we want to deploy it on Fargates. One team say that, okay, serverless is right. Every approach is right, but it becomes a nightmare for uh, DevOps team, operating, managing deployment. And this is the point where the deployment frequency of every team change. Uh, so far, I have talked to around about 50 companies, and only 3 companies are able to deploy daily. The least I have come across is 3 weeks, and for around about 40 companies that I have talked to, they struggle to deploy with more than uh, once per week. And why is that? Why is that? This is what the deployment experience become. It's not linear anymore. Now the deployment experience is coming down. The thing is that DevOps is such a large space, and with the industry that is moving at a very blitz scale, anything that you do is going to be obsolete when you wake up the next day. That is how fast the industry is moving, and we are solving a problem across a very wide landscape, with each area having a very uh, vast problem space, and we lose focus. We lose focus that, okay, our goal is to deploy daily. We lose focus. We say that, okay, we want to do Terraform, we want to do infrastructure as management, we need to have governance, we need to have compliance. This is where the team, and the most important thing is that because our team is growing, we need to have sort of a visibility into our CI/CD pipeline across multiple projects that give us a unified window. Individual teams are moving at a pace that they want to move, but we don't have the tooling that is there. That is what I'm talking about. What does it look like? Why do we have the problem? What causes this tipping point? I have already talked about that, okay, we have now merge conflicts, we now have configuration management issues, we have dependency management issues. This is what on top of, if we have to take a 20,000 feet overview of the system, this is what it looks like. But this is just the tip of it. If we are dealing with distributed system, there are multiple nuances that we need to make. What most people don't come is deploying a distributed system is a distributed system problem. So in the end, it becomes a state management problem. Release orchestration requires custom to build tooling that provides sort of durability to the volatility that is being manufactured by the pieces below. And then we are also dealing with very hard failure modes that, okay, we need to have the dependency management. For example, service A is dependent upon service B is dependent upon service C. So if a code change comes on repository B or service B, we need to deploy A, B, C, or the entire dependency graph in isolation. Then we have to do a sort of a controlled rollout that, okay, we are moving it out, we are deploying it and to a separate infrastructure. Now we need to sort of monitor that. And the entire piece of building this thing is a separate engineering effort and is a very expensive endeavor. This is why, after operating distributed systems and building these systems for the past 15 years, we have decided that, okay, we might have a common abstractions that deals with release orchestration as a whole, that should enable companies to deploy multiple times per day with confidence, and deals with the operational nuances such as merge conflicts, dependency graphs, make before break, or traffic draining. For example, even if we are deploying to a separate immutable infrastructure, there are already messages in the system. We need to carefully drain them before switching the traffic over. Then we need to do a control rollout, progressive delivery, 5%, 10%. Anybody who has done progressive delivery, even using tools like Argo or modern tools, Argo CD, Captain, or Octopus Deploy, these tools, they know that, okay, in order to operate these tools, the underlying fabrication for coordination needs to be built. What if it's already out there? You just have to do it via YAML. So this is what quantum is all about. It's not a platform, it's a framework that provides sort of programming primitives that deal with different challenges that come in release orchestration to enable teams to deploy multiple times per day. I hope that this talk helps you, and I hope that you find it useful. Thank you very much. Thank you, Saim, for the time. Thank you guys for bearing with me.